Hi, hello everyone. Um, how are you guys? Okay, so this is day two of our DSA solving series, where we will be solving DSA until we get a job, right? And today we are going to continue with the DSA sheet, as you can see here, and the DSA sheet, the master sheet that we were working on, this sheet, and we will be continuing on this sheet. This sheet contains all the questions that we need particularly, as I said in earlier videos as well. This sheet contains all the popular DSA series questions that you most likely follow, right? And we'll be doing the questions in this series as well. In the last live stream we did best time to buy and sell stock, majority of elements, removing minimum and maximum, which is a great question. It's a greedy based question. Then we did move zeros, then we did reverse string, add strings is also a good question. Then we have find pivot index, sort colors, where we learned about DNF algorithms. And we learned two types of algorithms in the last video. The one we learned was about Boy's Moore voting algorithm, which was a simple algorithm, but we were choosing in the candidate form. And then we were also doing in the form of verification. Like I'll just show you something. Okay, so if we have a majority of element question here, and so you can see here that in this question that we were finding the candidate as nums of 0, and then we were searching that if a nums of I candidate we reduce the count, but if the count reduces to 0, then we choose the current element as the candidate and we just reset the count to 1. And there's also a verification method in this. I don't know why isn't it here, but I'll show you the verification wala method as well. So in the verification method, basically what we do is we take the current candidate and we just increase the count whenever we see it. And if the current candidate is greater than n by 2, we just declare that it is the highest element, the majority of elements found in the series. So that's it from, yep. Let's just hide these tabs. Okay. Okay. So as I was saying that this is our you know thing we were doing in the last videos as well. And yeah, then we did a majority of element. Then we learned about DNF algorithms. In the DNF algorithm, what we were doing, we were taking in 2 pointer. Yeah, I like to call DNF algorithm as the follows. Okay, I like to say that a DNF algorithm, which is used for basically sorting three particular colors, maybe red, white, and blue, because it's a Dutch national flag algorithm, as it says. I would like to say it is a 2 times 2 pointer algorithm, nothing else. Okay, so we are swapping the values in like 2 times. So, for example, there is given a array of 0, 1, and 2, right? And we have to sort the integers in one pass. Okay, so the normal thing is you can use the sort method, but it is n log n method. Then what is a good method as well? So the good method is basically to use the sorting algorithms of making twice swaps with 2 pointers. So what I am saying is you need to make the zeros into one side, in the left hand side, and the twos on the right hand side, right? So you just swap the values in the first pass to make the zeros on the left hand side. Then you just traverse the array from the right hand side, and you just take the twos on the right hand side, and then just it's simple. So it's like two pass algorithm. So in the last video we were also making in sure that we were just solving in here. Okay, so this is our marker in a repository, as we discussed in the previous video as well. So in this marker in a repository we have all the questions that with templates of what we are going to do in the master sheet. So we are going to solve it here, we are going to debug it, and we are going to learn how the debug thing works. Okay, as I said in the earlier video as well, why I am not doing directly on the lead code for in the lead code, which we can do. It is because in the normal tech interviews you are not allowed. I would not say allowed, but I would say that it is not much recommended that you use directly the function writing. and not just a full code, because they expect you to write the full function code, they expect you to write the full main code of it, and they expect you to write, the complete code of it. So it's good that you basically like align and adhere to the limits of it. So in this we are going to learn about it. And from the arrays, strings, hash tables, two pointers, prefix sum, sliding window, cadence, linked list, and all those things, it would be easy. Stacks and queues, this will all be easy. The main reason why the writing main code will be difficult when we start with trees and linked list, because in trees and linked list there is not simple like making arrays and something, right? We would be writing hefty amounts of helper codes which is already written in it, but we will be understanding what those helper code means, because now we have to make maybe generating a tree from a maybe we have to like generate a tree from uh, generating a tree from maybe what I would say from an array, right? And we will be generating the list from an array, we will be generating trees from array, and then we will be uh, printing those trees, then we will be printing those trees in the order that they wanted. So it's a lot of helper codes that we would be writing. We would have to learn how to write helper codes, because then I was just seeing the Google interview a few days ago on YouTube, and they were saying that you have to write the code in Google Docs, right? So it's like difficult thing, no, because we haven't write anything on Google Docs. So that is why it is important that you adhere to the limits of it. Okay. So the last video we were doing this beautiful question called pivot index. Okay. We will debug this once again. I'll just format this code. Okay. We will debug this code again, and I am just going to copy paste this entire code into this question that is called the final middle index of the array. Literally copy paste, and this will be the first question of the day, and then we will move ahead to the next questions. Okay. So okay, so that's it from my side. And yeah, let's discuss something. Okay, let's code up something out. Okay. And hmm let me just give me just 1 minute so I can just check if the stream is working right. Okay, say the voice is coming or not, and all the issues, it would be like handled. Okay, let me just check it. Give me just 1 minute so I can just check declare that it is the highest element, the majority of elements found in the series. So that's it from, yep, you have to sort the integers in one pass. Okay. So the normal thing is you can use the sort method, but it is n log n method. Then what is a good method as well? So the good method is basically to use the sorting algorithms of making twice swaps with. Okay. So I think it works, right? So yeah, let's move ahead. Today also we have some music with us, but let me just check that if I had like mentioned it. Okay, okay, right. And I'll just copy paste this in the this as well. Okay, so let me just take a screenshot of it. Yeah, it works. Okay, and let's change the music a little. Okay, so we have this new music as well with us. It's called Chill Hop. Okay, so it's a good music. Okay, we'll be listening to this music for now. Let's also declare this as well. Music also provided by. Okay, so it works. Just wait a second, and yep. Wow. Okay, so it's let's code now. So in this question, we will be given the I like the debug function, debug feature of this intelligence. So good, so good. नम्स नाम की array बना दी, लेफ्ट नाम की array बना दी, राइट नाम की पूरा दिखा रहा है ये, पूरा debug करके. Let's just move to the next step, and it traverses to I to 1, and then the new array becomes I2. Why is it becoming I2? Because we know that the left of 1, this is the 1, is equal to left of I minus 1, that is left of 0, that is 1, plus nums of I. Nums of I means nums of 1. What is nums of 1 here? Nums of 1, 7. So 7 plus 8 is 7 plus 1 is equal to 8. And then we just move to another step. Okay, so it becomes to I is equal to 2. So what is I is equal to 2 here? I is equal to 2 here is equal to I left of 1, because 2 minus 1 is 1. So left of 1. Left of 1 is what? 8. We found it 8 right here. And nums of 2. So what is nums of 2? That is 3. So 8 plus 3 is equal to 11. So it is showing 1, 8, 11, right? Exactly. And then we'll just move ahead, and then it will fill the left array. And after filling the left array, we'll move to the right array. Now the right array will be traversing and moving from the backwards part of it, right? So when we move into the backwards part of it, it would be, the first element would be 6, then it would be coming into the next part, and then it would be 11. Now why is it coming 11? Right of n minus 2. So what is n minus 2 here? Okay, so n is, what is n here first of all? So n is 6. 1, 2, 3, 4, 5, 6. There's 6 elements. Okay, the last element was 6, so it would be 4th element. So 6 minus 2 is equal to 4. Now when we in the fourth, right of 4th is equal to right of 4 plus 1, that is 5th. यानी कि ये वाला element, ये वाला element. Okay, right of 4th. 6 minus 2 is equal to 4th. So the 4th element, that is right of 4, is equal to right of 5th plus nums of I, that is on the 5th element, right? So it will be showing 11 here. And then we'll just move ahead, and then simultaneously fill it. And what we are finding the element, the pivot element, if the left value is equal to right value. If any value of the left hand side is equal to right hand side, we found the value. So can you see any value on the left hand side that is equal to right hand side? Yes, we know what is the value of left hand right hand side. That is 17 here. 17 here. So it's giving me answer. If left is equal to right of I, return the I element. Simple. Now a question that may arise with you guys is, 28 is also same as here, left and right. So why is it not the element that we have written? See, left of I is equal to right of I. The I is going to be constant. Understand? This is left of 5th element. This 28 is left of 5. and this right is 28, that is right of 1. So right of 1 is I, and left of 28 is basically fifth element. So 5 is not equal to 1, right? Left of I should be equal to right of I, that is element number 3. So left of 3 is equal to right of 3, and then we know left of 3 is equal to right of 3, and then we have to return I, that is the third element of the set, right? So we return third element, that is we return the I 3, and then we return minus 1. Okay, so coming back to it, now it will check, is it equal to 3 here? It not. Is 1 equal to 3 here? Right, is 1 equal to 3? Now see here, is I is equal to 1 here? Maybe just view here. No. So is 1 equal to 3 here? No, it's not equal to 1. So it moves ahead. No, it's not. Now when it comes to 3, it basically is going to be true right now. 0, 1, 2, 3. Now 70 is equal to 17, it returns true. So it returned true here because it found the I, it found the condition, and it will return 3 here. And the statement is completed, the main statement is closed now, and it will return 3 answer as here. Now I will just copy paste this answer entirely into my answer. Just copy paste entire answer. Okay. So no, it's going to be okay. Okay. And where was this question? Yep. Right. And yeah, it runs exactly. We haven't done anything. Accepted 100%. Good. Okay. What will the time complexity of this? We have been making two arrays, left and right. So it would be space complexity of big O of n. But what is the time complexity of big O of n? Same. Let's just check also big O calculator. It's a good calculator, by the way. We should all please use it. Okay. The code aim to provide a fundamental index from left to right. So big O of n plus big O of n plus big O of n is equal to big O of n. Two auxiliary arrays left and right of size n are used. Additional variables constant space big O. In summary, the algorithm runs in linear space. Got it? I think it works good. Okay. So yep. Okay. So let's do something else. Let's do a good question. Let's just refresh it if it's working or not. Extension should be working, right? Yeah, it's working. It's working. Find the middle index of the array. Yeah, just 1 minute. Okay, so let's just use a new question. And this was the sheet here that we were solving questions yesterday. We will be doing questions again. Let me just create a new file, page number 4, right? And then we'll just share this page again. Let's share this page. Wait a second. Right, so let me just check this out. Yeah, it's working. It's working. Okay, so okay, so I think it works. Let's do a new question now. What shall we do? What shall favorite question, favorite of favorites, like ultra favorite. It's called twosome. Twosome is a great question, greatest question ever existing in humanity is this question. Okay, let's do twosome now. I will tell you two approaches to this question. Approaches. Approach one, brute check, and approach two, hash check. There's also two kinds of approaches here. Another approach. What was that approach? Give me 2 seconds. Let me just think of something. Okay. So if we like 11, 18, 30, and 32. Hmm. 18, 30, and we make something like 2, 24, 31. Yeah, it's not working. It's not working. Okay. Oh, sorry. Yeah. I was thinking of something, but it's not working. Okay. So yeah, it's two approaches for now. Okay. I was thinking that maybe we could use some prefix, some kind of approach here, but yeah, it's currently not in our check. Okay. So we'll do twosome here. Let me just tell you this question, and then we can continue. You can also just directly jump into the question. Okay, so given a question, we have been given an array, and we have given a target value that's called 9, and we have to find the indices on which it could end. I have made a reel of it, by the way. It's not out yet, no, but I'll share you the link. Okay, I'll upload it one day for sure. And yeah, this question is actually great. Simple है बहुत. Can you come up with an algorithm that is less than big of n time complexity? We will be doing big of n time complexity. We will be reducing the big of n time complexity. Let's see the hints. Really brute force. Let's Let's just do this. Okay, let's just do this once, and then we can continue it. Let me just tell you this question once. It's a very simple question, to be honest. Suppose we have been given an array 2, 7, 11, 15. Where is this? Oh, right. Now we have to find the indices. Okay, we have to find the numbers in this array that would be equal to that would be equal to basically 9. So we have a target that is 9. Hmm? Okay. Now what can we do in this question here? क्या लगता है इस क्वेश्चन में क्या कर सकते हो? देखो पहला क्वेश्चन तो ये है, हमें ये पता है इंडाइसेस, हमें पता है कि हमें दो एलिमेंट पता लगाने हैं जिसके जो नंबर है वो सम के टारगेट जो है वो 9 के इक्वल बने, वो 9 के इक्वल बने। हम्म तो हम क्या कर सकते हैं इस क्वेश्चन में, क्या कर सकते हैं, हम क्या कर सकते हैं? ये नहीं कर सकते कि व्हाट इफ वी इन अ वेरी similar dejected kind of solution but still working, is that we can use maybe twin loops. Okay, nested loop ले लें हम एक। nested loop में क्या करें, we'll take a for loop of I hmm, and we'll take a for loop of J, and they will both run together, and in any case we find that nums of I plus nums of J is equal to target return I and J। सिंपल, दो बार लूप लगा दो, नम्स ऑफ आई और नम्स ऑफ जे अगर टारगेट के इक्वल है तो काम कर दो। ये है पहला अप्रोच, और अच्छा अप्रोच है, टू बी ऑनेस्ट, काम करेगा ये भी। लेट्स जस्ट यू नो व्हाट, लेट्स जस्ट रन दिस वंस एंड देन वी कैन then we'll come to a good solution now. Okay, let's just run this one, I'll tell you something out of it. Okay, let's just run this one. Let's just check the brute force check. Okay, first of all we have to check the return type of it. So we have to return the array of integers. Now what we have to return, the array of integers that is summing into the target, right? Let's just check two things. Let's just make a new uh, array. Int arrays is equal to new int of 2, hmm? And right, 2 int of 2 rest हमें निकालनी है। Now we'll take two for loops, int I is equal to 0, I less than n and I plus plus। हमें अभी n अभी डिक्लेयर नहीं करा n क्या है, but we will just do it, and yep, and then we will take for int j is equal to um, 0, what, not j is equal to 0, it's going to be 1, and is it going to be 1 or mm, let's say j is equal to 0 for now. Okay, let's just take it, j less than n and j plus plus, sorry, j plus plus. Okay, and we'll take why is it coming this way? Okay, so we'll take n is equal to n nums dot in. Simple. And what we're going to do here is that if nums of I plus nums of j is equal to target, uh, so we have rest of 0 is equal to I and rest of 1 is equal to j. Hmm? Simple. And immediately we return, uh, not immediately, let's just return, let's see. Okay, let's check this. Test case in general 3 1. Test case of I. I think इसमें थोड़ी गड़बड़ हुई है. G of I. I think G of should be I. But let's check this. 1 1 expected 0 1 0 1. Why is it giving this question? Is it going to be I? For int I is equal to 0, I less than n, I plus plus. For int j is equal to I, j less than n, j plus plus. Let's just write this whole again. For int j is equal to I, j less than n, and j plus plus. Let me just think of it. Okay, let's just debug it. Let me just see what's going to be the problem here. Okay, let's just debug this first. हमें आइडिया लग जाएगा ऐसे. हाँ तो n 4 I 0 target 0 I 0 J 0 I 0 J 1 I 0 J 1 I 0 J 2 I 0 J 3 I 1 J 1. Oh, so it's like summing its own. Okay, तो हमें ये नहीं करना. So it's going to be I plus 1. Let us debug this once again. So once it does this, I 0 J 1. So I 0 J 1. So 11 plus 7, 18. Okay, 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 okay. I 1 J 2. Okay. Yep. Okay. Target 9 J 3. Yeah. Yeah, yeah, yeah. And J 1 I 3. Rest 1 0, J 1 3. Then it will return again. So it's like running unnecessary out of it, but we have to find just one solution now. So we'll just break it. We'll just break it. Unnecessary क्यों loop कराएं इसे? And then it will just return the answer once it found it. Okay. So j is equal to 1 इसे मिल गया. इसने वैल्यू भर दी. इसने जैसी वैल्यू भर दी इसे मिल गया. रेस्ट इज इक्वल टू 1 कर दिया. इसने ब्रेक कर दिया. अब यहाँ से ब्रेक हो गया. इसे ब्रेक करना है ना. इसे यहाँ से खत्म ही कर देना है. हो गया. Done. Return rest 1 and 3. Okay, so it works. So this is a nested loop wala approach. Okay. Uh, yeah. Okay. Okay. So you can just paste it, right? And you can just run it also. So it will work. But the time complexity here is big of n square. As you can see here, it's big of n complexity, n square complexity. So it's not a very good option here. Now, let's think of something else. Okay. Let's think of something which we have calculated out of this. Okay. Can you see something in this approach that we have just find out? Okay. Can you see something? We have nums of I plus nums of j is equal to target. Okay. Let me just bring up my whiteboard here. Okay. Let's go ahead below it. Okay. Can you see something? When we say nums of I plus nums of j is equal to target. So what are we saying particularly here is, for example, I is equal to 0, that is 2 for now. Some anything, maybe it's like 2, and target is like 9. So nums of j will like traverse over each of the array. For I is equal to 0, nums of j will traverse first for 1 and 2 and 3 and 4 and 5 and 6 and 7 and whatever types of elements are in this array, and it will bring combinations out of it. So nums of 2, so 2, that is the nums of I, and it will traverse over nums of j, maybe like 7, 11, 17, 24, 31, 38, anything out of it, that is the nums of j. And in this nums of j, it will traverse up to it until it finds something called answer. So for example, 2 plus 7 we have found here. Let me just take another color. So for example, it found 2 plus 7 here, and it will return the indices, yeah, that is 1 comma 2. Hmm? So it is taking the nums of I once and is taking all available. Now the I for I of 0 it is working. Now what is happening inside the second loop? What is happening inside the second loop? Now I is equal to 1. In this I is equal to 1. Suppose we have not find out answer. Suppose this is like another test case. Okay, so we have, so this test case was good. We created ourselves this one 11 7 2 11 7 2 12 2. Okay, so in this test case 11 has been gone. So suppose now I is equal to 1. Now I is equal to 1 पे यहाँ पे वैल्यू आई हमारी 7. So nums of j will traverse to how many elements? It will traverse to 11, it will traverse to 7, it will traverse to 12, it will traverse to 2. प्लस करके देखेगा इन सबसे वैल्यू से. नम्स ऑफ जे तो केवल एक ही कांस्टेंट आई रहेगी. नम्स ऑफ जे पे वो इतनी बार ट्रेवर्स करेगा, दैट वी हैव सीन इन debugging as well. That is why we are taking twice loops. And whenever it found here, and whenever it found that 2 plus 7 is equal to 9 here, it will return the indices, and what are the indices here? That is 1 comma 3. But the main formula that we were getting in this particular checkpoint is just very simple. What was the formula that we were getting here? Right? What was the formula we were getting here? We were getting the formula that if target, so we were knowing that if target I plus j is equal to target, very simple. We were thinking of this way, na? We were always thinking of this way. We were not thinking of any other way. If I plus j is equal to target, we find the answer. So can we say that I is equal to target minus j? Simple maths. Very simple maths. I'm not thinking of anything else. Simple maths. If I am saying that I plus j is equal to target, I've just taken j over there. It is called target minus j. So whenever we find a particular element which matches the target minus j in the array, I can say we found the answer. And which is the best data structure that can help check any element inside the array in just big O of one lookups? Hash maps. Big O of one lookups के लिए hash maps. Any time the target minus j matches any element inside the array, I would have found the answer. For example, target minus j, that is 9, and suppose the j coming out here is, and suppose the j coming out here is 9 minus 7, and inside the hash map we have values according to the frequency part, that is maybe 2 comma 1, 11 comma 2, 17 comma 3, 7 comma 4, any kind of it, maybe 0 1 2 3 4, for in this case I forget it was an array. and anytime it found maybe 2, it will just check in big of 1 lookups and it will return the answer. Simple, very simple. This is what the logic of two sum approach is. I think it's a, I think you have got what I'm trying to tell you. Okay, got it? Okay, let's just code this out and finish this. Let's take a complement into x. Let's take it x is equal to target minus j. I have to find the j one. Okay, so let's take it. So I find like I plus j is equal to target. So x plus y is equal to target, right? So if we take target minus y, that is the nums in this array, then we can find the answer, right? So what we can do is simple. Let's just take for loop again. Let's just take a for loop again. Now if map dot contains key, because we have to find the key, not the value of it, contains key what? Target minus nums of I. And what is nums of I here? We discussed it, right? That is, it is as simple as target minus j. Target minus j is equal to x. Simple, the formula that we were always working on. Then what we can do is res of 0 is equal to I, and res of 1 is equal to, not res of 0 is not equal to I would say. If x plus y contains z, then I think it would be yeah, I think it would be I, and then map dot contains key value. No, I made a mistake. There is also one more thing I have to tell you. First of all, there is also one more thing. Just tell me. Let me tell you. Small thing. Suppose the array is 3, 3. Suppose the array is 3, 3. Indices are 0 and 1. And target is 6. So 6 minus 3 is equal to 3. So it can return the same element as well. But 0, 0 is not a valid answer because element is only 1, but it's summing to 6. So we have to also check that if I is not equal to j, and then we have to return the final answer. Okay, so that is the only thing that I was just telling you. Okay, so this was the only thing. So we have also to check if I is not equal to 0. me just, you know what, I'll just gonna switch on my camera for a bit. Okay. If map dot contains key target minus I, then we have found our element. Okay. So what we can do is target minus int x is equal to map dot x of target minus I. Okay. So if x is not equal to I, then we have to return the value that res of 0 is equal to I and res of 1 is equal to x. And then we have to return the x. Okay, so let's just control 5 inch. Putting the value here. Okay, let me just 2 comma 7 comma 11 comma 12. Okay, let's just do it again. Okay, so the value is working fine. It's giving me 2 1, it's giving me 1 2, not working here. So it's giving me 3 comma 3 here, but it's like adding one more element into it. Okay, so why is it doing it? Okay, so map contains key target minus nums of I. X is equal to map dot get target minus get get map dot get okay. Target minus nums of I, map dot get int x is equal to map dot get target minus x, and x of not equal to I is equal to x. Okay, so let's just remove this check code. Let's see one thing. Is it like fitting things? No. So we have to check if x is not equal to 0. For int I equal to map dot not map dot put if map dot contains target minus num. You know what we can do also in this single for loop. Let me just try that. Target minus num, then we have rest of 0 0 map dot get target and 1 is equal to num. Simple. Let's just run it. Oh, it's taking one. Num. Default num target minus num target minus nums of num target minus nums of num. Okay, and map dot get num been working on this question for the past maybe, I don't, let me just see this. I have been working on this problem for I don't know, like 15-20 minutes, and I don't know anything about this question right now. What the hell is this question? It's an idiotic question, literally. I am not doing this question. First of all, there is no way I can crack this. क्या क्वेश्चन है ये समझ ही नहीं आ रहा. दिमाग खराब हो गया 15-20 मिनट से. कर ही जा रहा हूँ, कर ही जा रहा हूँ, कोई नहीं रहा कुछ इसमें. Just save this answer. इसमें करना क्या है इस प्रॉब्लम में? ओके, मुझे इतना पता है पिवट एलिमेंट निकालना है, उसके अराउंड ही चीज घूमेगी ये. तो अगर हम एक नेक्स्ट एलिमेंट निकालें जो जस्ट ग्रेटर हो प्रीवियस एलिमेंट से, तो कुछ हो सकता है क्या? Let me think of something. क्या घटिया क्वेश्चन है वाकई में, मेरा दिमाग खराब हो गया. फाइंड डुप्लीकेट, तो ये तो है ही बकवास क्वेश्चन. बट ये समझ में आ गया था कि पहले हमें डिटेक्ट करना है रिपॉजिटरी पर. डिटेक्ट फर्स्ट any changes. Detect first any loop. This is one of the most bullshit problems I've ever faced in DSA. One of the most bullshit problems ever, ever, ever. Given an array, I have to like मुझे तो दिमाग ही समझ में नहीं आया, मेरा दिमाग फट गया ऐसे सोच के भाई। एक एरे में मैं कैसे किस तरीके से वो पैटर्न पता लगा सकता हूँ कि नेक्स्ट ग्रेटेस्ट इंटीजर जो इसने निकाल के दे रखा है यहाँ पे, ये रहा नेक्स्ट ग्रेटेस्ट इंटीजर निकालना है, उसके बाद फिर उससे इसको स्वैप करना है, स्वैप करने के बाद पूरे एरे को उससे रिवर्स कर देना है। हाउ एम आई गोइंग टू थिंक अबाउट दिस? अगर ये क्वेश्चन पेपर में उसमें आया था तो इंटरव्यू में आया था तो ये क्या क्वेश्चन है? घटिया सा क्वेश्चन एक नंबर का। क्या बकवास क्वेश्चन है वाकई में यार ये। आई कैन बेट लाइक अगर ये क्वेश्चन किसी ने पहली बार में नया देखा होगा ना तो नहीं, आई डोंट थिंक सो कि वो उसे क्रैक कर सकता है। आई बीइंग ऑनेस्ट विद myself that you cannot you cannot solve this if you haven't seen this before. You cannot. And I'm being very dead honest right now. This is one of the most bullshit problems I ever faced. Useless, idiotic questions. My god. Idiot question. Such a useless question. Let's let's hear some good music. बहुत देर हो गई अब, synthesis सुनते हैं. Wait, let me just switch it out so you can also listen to this. Chill music, hip hop era. Idiotic question, literally useless, worst piece of shit. Cannot solve this if you haven't seen this before. I'm guaranteeing it. Useless. Let's do something. First, given an unsorted integer array terms, return the smallest positive integer that is not present. इसमें जीरो क्यों नहीं आया? -1 पे तो जीरो ही आता है। Oh God. How don't you worry about my boyfriend? Text can question you hashed him? ये hash का question है? Think about how would you solve the problem in non-constant space when you apply that logic to existing space. You don't care about duplicates, you want positive integers. Hint 3. Remember that plus 2n is equal to 05. 0, 1, 2, then you have 3. Numbers in the range 1, 2 are all in the array. 3, 4, -1, 1. So 1 is in the array but 2 is missing. Given an unsorted integer array num sorting the smallest possible integer that is not present in nums. You must implement an algorithm that runs in big O of n time and uses O of 1 auxiliary space. Okay, so we are doing this question and then we'll take a break. Okay, cool. 1, 2, 0, and then we have 3 here. Okay, 3, 4, -1, -1. Okay. Let's run some cases. You know what? Let's find a question first. First, let's see what comes. Okay, first is what's which minus x into so even if we let me see okay, okay, putting on this question here again it's a basic operation we follow basic operation of I give a hash key present I give a hash key and it's a hash key that basically means we else but what is the case here that we cannot use an extra space complexity, right? So if we ever we can use something like this, make a new array, make a new array. Let's name this array res, and we add all the elements in this, all the elements, all the elements, all the elements. So we add 1, 2, 3, 4, 1, and we traverse the array. So maybe if we export it, so we can export it. And if we export I let's take another example. Suppose I can take out a main integer array. So if min of the array is greater than 1, the min is always 1. Basic thing. If nums into 1 is equal to integer of max, or I into 1 if min is greater than 1, greater than, but always return 1. अब सारा केस else सारा केस अब else में समझ गया क्या आएगा। अगर कोई भी वैल्यू अब इनके इक्वल आती है तो हमेशा माइनस में नहीं होगी, चाहे कोई भी वैल्यू आ जाए। फॉर एग्जांपल इफ आई टेक अ टेस्ट केस ऑफ maybe here, so I'll take this case, okay, and I'll create a new test case, maybe so it is always going to be 1. Yep. See, always going to be 1. Every time the minimum of element is going to be increasing than 1, it is always going to be 1. But if 1 is present in the case, every time we are going to see that we are going to find कि ये 1 के इक्वल होगा। बट व्हाट इफ ये 1 ना हो? मेरा क्वेश्चन तो यही है ना, मुझे तो यही पता लगाना है अगर इसमें 1 ना हो। For example, if 1 is in the array, if array contains 1, then I have to find the next greater increasing number. Got it? And if 2 is also in the array, then I have to find the next greater increasing number. So I'll have to find a range of numbers for that number. Yeah, getting it? So if I have a new array, let's take it same example. 3, 4, minus 1. How am I going to find that particular number here? Have 3 what if I take a space? तो मैं स्पेस ले लेता हूँ, मैंने स्पेस ले ली, मैं क्या करता हूँ इसको? तो स्पेस लेने के बाद मैं केवल 2 चीज़ें कर सकता हूँ, या तो मैं उनको सॉर्ट कर दूँ, सॉर्ट करने के बाद में फिर बेसिक थिंग। इफ आई कैनॉट यूज if I use the sorting space, I can use sort did -1, 1, 3, and 4, right? And what we did do is we basically we remove these numbers. So array becomes this one, 134. Now in this 134, shall I show 3, 4, 1? I have to find the next positive integer in the array. So then I have to find the minimum and maximum of this array, that is the 1 and that is the 4. Now in this 1 and 4 I have to find what numbers are present in this array from the minimum to maximum, and then I have to find. So for example, from 1 to 4 I have integers from 1, 2, 3, 4. Now every time I have found the missing number inside from the nums.auto, then I can return it. And if nums.i is not equal to, if nums.i, if map dot contains I, if map dot contains I, return that integer, right? Minimum to maximum, that's how we run it. Okay, so let me think of something else. So अगर minimum यहाँ पे काम नहीं बनता तो I'll just return 1. Every time I'll just return 1. I'll remove this function also. I was thinking अगर min मेरी ये value है तो if min is this, so I'll find the maximum this way. I'll find the so min में तो ये मुझे -1 ला के दे देगा, -1 तो मुझे चाहिए, तो मुझे -1 ला के दे देगा. So my first target is to eliminate all the negative integers from the array. So for int I is equal to 0, for this is going to be clean minimum to be found, okay? And this is going to be removing each negative from this array. Okay, so this is going to be every integer removed from this array, or every negative from this array. So if nums dot I is less than 0, what am I going to do? How am I going to remove this? But I have to also see ना कि अगर मेरे पास nums of I less than 0, if nums of I is less than 0, तो मुझे कुछ भी नहीं करना. I have to create that number from nums of I. So I'll just can set it from I can just set it to 0. Nums of I is equal to 0. Can I do that? Yes, I can. Yes, minimum positive integers. Okay, and yeah, I think I'm going right. Okay, so if it becomes 0, if the element becomes 0, then suppose we have an integer of maybe 3401. Okay, so we have 3401. Now if the check of minimum is basically doesn't contain any kind of 1 in it, it contains maybe like 0 in it, then the next positive integer is always going to be 1. Because if it doesn't contain if minimum is always greater than is going to be greater than 1, then I have to always return 1. And minimum is equal to 0, then always return 1. Minimum is always greater than 1, then I have to just return 1. Like all cases of my positive integers, if there is no negative integers out of it. Okay, but all integers are positive. Getting my point? When all integers are positive, greater than 0. Then I'll have to just check if none of y is equal to 0. तो इसके लिए तो ये काम करेगा, इसके लिए तो ये काम करेगा, डेफिनेटली करेगा. I'll just get to know. So now if my array is basically suppose my array is basically 0, 2, 4, 5, 6. Then the minimum of here is 0, and if 0 is going to be less than is going to be or min is equal to 0, then return 1. Either min is going to be greater than 1 or min is going to be equal to 0, then I always have to return 1. Getting my point? What if min is equal to 1? What if my min is equal to 1? So for example, if I have this array called 0, 1, 2, 4, 6. Now minimum is 1. Now minimum is 0, but I have 1 also. So if minimum is greater than 1, getting my point? So for this particular thing, right? So it failed here. It failed here. I have to write something. So first of all, I have to remove this. Let's think of something else. For now, in this particular kind of array, for now, every negative integer that is going to be in this array, every negative integer is going to be placed as 0. So even if so for example, even if this array was containing 3, 4, minus 1 and 1, then the value of this array is going to be, for example, if I change to array void and I'll just do basically a first missing positive 0, and then I'll just do basically first missing positive. Okay, I'll just do basically this, and I just basically run this. What is going to be done here? It's going to basically arrays dot toString nums. So what is going to be done here? Oh, if nums of I is less than 0, then nums of I is equal to 0. So it does 0 here. So now I have 0 in this array. I don't have anything, but I have to find the next greatest integer equal to Let's see what we can do here. I'll bring the link here. Now I have cleaned the array. Now there is not going to be any kind of it would always going to be either 0. The first hurdle that we have to find out is now I have to find two things. I have to find the min, range, and max. So int min is equal to max value and int max is ये मेरा काम हो गया है weekly, and then I'll just come out of the loop, and then I'll run a new loop, because I have to now find the integers for int I is equal to min, I greater than max. But I have to store it somewhere. doesn't contain here. If nums of I is less than min, then I have to find the then min is equal to the number and return min and return min. Otherwise, return min is null. Let's see. It doesn't fail this. Okay. To find it, change it now. Going to be changing and this and this. So static public int return -1 ठीक है. तो first message positive and nums -1. Or if I plus 1, if I plus 1, for example, the range is 1 to 4, right? I have the minimum integers in this range. Now इसी के अंदर ही लाई करेंगे सब कुछ, या मिनिमम 1 ही रहेगा, मैक्सिमम कितना भी आ सकता है. आई डोंट केयर हाउ मच. अगर नम्स ऑफ आई मिनिमम से छोटा है, नम्स ऑफ आई यानी कि जो 1 ही होगा वही अगर छोटा हो गया उससे, फिर nums of I, even if I is very less than max, so it's not going to be nums of I guess. If it's not nums of I, it's just I. If I is less than equal to min, then min is going to be I, and then I have to just return min I. Return min. Then into new min. Into new min is equal to I, and then we have to return new min. Okay, so yeah. Int new min is equal to 0, and we return here. 3, 4, 5, 6, 7, 8. Right, down, left, top, right, down, left, top, right, down, left, top, right, down, left, top, right, down, left, top. RDLT. Right, down, left, top, right, down, left, top. So this is going to be right, down, left, top, right, down, left, top. right is equal to nums of 0 left left top left right पूरा left पूरा वो तो जब तक मेरा टॉप छोटा है मेरे बॉटम से और मेरा जो लेफ्ट है वो मेरा किससे छोटा है, मेरा राइट से। अब मैं ट्रैवर्सल शुरू कर सकता हूँ, ठीक है। तो पहले मुझे ये चेक करना है फॉर इन आई इज इक्वल टू लेफ्ट टू राइट पहला केस लेफ्ट टू राइट, तो रेस्ट डॉट एड टॉप ऑफ आई nums of top rest dot add nums of top and what we can do here is we can top minus top plus एंड सिमिलरली अब हम लेफ्ट से राइट गए, अब हम आएंगे टॉप टू बॉटम हाँ। तो अब हम जाएंगे इंट आई इज इक्वल टू टॉप टू बॉटम, तो रेस्ट डॉट एड नम्स ऑफ आई तक जाना है हमें, तो हम आई से आई अगर अभी भी जो टॉप है वो आपकी अगर कम है बॉटम से, और ये है अगर, तो मैं जानता ऐसे आ गए हमें यहाँ पे हम हैं लेफ्ट में, तो हमें ऊपर जाना है, तो हमें टॉप पे जाना है। सो इफ लेफ्ट इज लेस देन राइट, तो फॉर टॉप टू बॉटम हमें लेफ्ट डाल देंगे, एंड देन वी गोइंग टू डू लेफ्ट प्लस एंड ऐसे हमें यहाँ पे करना चाहिए एंड बॉटम माइनस एंड let's walk through this. Okay, let's see. Please walk me through this code with an example to help me better simulate cases. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. Starting row, bottom ending row, left ending column, starting column and then ending column. And we traverse this. Right down, left up. Right down, left up. बीच हमने गलत है. Okay, so initial state में top 0 है, bottom 2 है, left 0 है, right 3 है. Okay, how? Because we have okay, so top is 0, bottom is 2, then num stop length. Num stop length. That is num stop length basically 2 है. Num stop length minus होने की. या 2 एंड अप जो है वो भी हमारा 3 है, देन रेस्ट हमारा एम्प्टी. तो मैट्रिक्स इंडेक्स भी क्या है, यही है. ठीक, 0 0 0 1 0 2 0. व्हाइल लूप आइटरेशन 1 कंडीशनल. जब तक टॉप हमारा बॉटम से कम है और लेफ्ट हमारा राइट से कम है. टॉप हमारा क्या है 0 और बॉटम से कम है 2 और लेफ्ट क्या है हमारा 0, तो राइट से हमारा कम है 3. तो मूव राइट. अभी हमें राइट से चलना है, ऐसे चलना है. जब तक हमारा फॉर इन i इज इक्वल टू लेफ्ट से राइट i प्लस प्लस हमें मैट्रिक्स में सारे टॉप एलिमेंट्स ढूंढते हैं. वी ट्रेवल्स मैट्रिक्स 0 0 मैट्रिक्स 1 मैट्रिक्स 2 मैट्रिक्स 3 ये सारी रो बढ़िया यारी यारी रो वाली सारी हमारी ये 1 2 3 ये वाली 1 2 3 4 सारे डाल दी. अब we have used 1 2 3. now we have used the top row, so top plus plus. why? अब टॉप हमारी 1 हो गई है, एक टॉप हमने डाल दी है कंप्लीट, तो अपनी टॉप जो है वो 1 के बराबर हो गई. अब हमें डाउन चलना है, यानी कि राइट कॉलम से डाउन चलना है, राइटेस्ट कॉलम में डाउन चलना है. तो टॉप से बॉटम i प्लस प्लस रेस्ट डॉट एट मैट्रिक्स में राइट गए थे. वी ट्रेवर्स 8 and 12. ओके, राइट कॉलम इज डन, सो राइट माइनस माइनस राइट इज इक्वल टू 2. नाउ मूव लेफ्ट बॉटम रो ओनली इफ टॉप इज लेस देन इक्वल टू बॉटम. टॉप इज लेस देन इक्वल टू बॉटम. सो अगर हमारी इफ we have not traversed all our top bottom, तो अगर हम अपने टॉप पे सारा खत्म नहीं करके आएंगे, हो सकता है कि हम टॉप को ही वापस ट्रेवर्स कर रहे हो. दैट्स व्हाई देन हमें लेफ्ट राइट मोस्ट कॉलम में थे और हमें लेफ्ट मोस्ट कॉलम में जाना है, तो राइट से लेफ्ट चलेगा सारे बॉटम को. एंड देन वैल्यू का इटरेशन के देन मूव राइट नाउ चेक कंडीशन अगेन. ओके, तो यहां पे आ गया मूव राइट टॉप नाउ, तो हम यही चलेंगे. Why it's difficult to understand the if cases. Okay. Uh, just a second. Okay, so well, thank you again for coming into the stream. We have coded some good questions today. Let me just check how many questions we did today. Okay, not here. I should, yeah, in the master. Okay, so let it just basically uh, just wait a minute, guys. Okay, so we did today one, two, three, four, five, six, seven. We did seven questions today. Still less, but still it's good. Okay, so yeah, we are going good. दो तीन चार पाँच छः एक दो तीन चार पाँच छः सात आठ नौ 10 11 12 13 14 15. So we did 15 questions till now. We still have more than 250 questions. So we are not on a very good speed. But still, if we get easy questions on the way, because I think we have done most of the patterns in array. Now we have to just like repeat everything out of the context, and we'll just practice it all along the way. Today we did some very good questions. We weren't able to solve a lot of questions, like Pascal's triangle was a good question, and this stupid question. I'm hating this question for my life now. Next permutation. It's a very difficult question. Very difficult question. And the cyclic sort question, which was the cyclic sort one, no. Duplicate number, no. Missing positive, I guess. Find the first missing positive. It was a very good question. I didn't know if I have done this question before, but it's a very good question. मतलब इसने दिमाग के घोड़े दौड़ा दिए मेरे बढ़िया तरीके से. So it's a good question. And yeah, it's a hard question. So oh, it's a good question. It's a beautiful question. That's it from my side. We'll continue tomorrow. Same channel. And if you are liking, then please, stop by, maybe say hi, and subscribe, comment, whatever you do. And thank you. And good night, everyone.